We are now beginning a new chapter, and this new chapter deals with the question of economic growth and ideas. Specifically, how can ideas, invention, get us out of the diminishing returns trap that we seem to be in? Once we stop thinking about the solo model, there is an alternative way to explain why economic growth happens, but even better, a way to explain how economic growth can be so fast and so global, even in a physical world with scarce resources. So the story begins with the economist Paul Romer and others have suggested a way to explain fast economic growth that seems to contradict the limit of diminishing returns. And the fundamental idea is that private goods and objects are rival in nature and are subject to that kind of growth limiting problem that shows up in the solar model. So for example, you build a car, you've used some resources. Those resources cannot be used then by somebody else to build a car. I built a car for myself. That means maybe you can no longer build yourself a car. So this is this trade-off idea that's a basis for standard microeconomics in the classical sense. Everything is about optimizing limited resource. Trade-offs are everywhere, and benefits to consuming a good or utilizing a piece of capital or utilizing a worker, those benefits decline on the margin. Now, if this was the end of the story for explaining growth, we would expect that eventually all countries will converge and flatten out and reach some kind of upper limit to growth. The idea is that the richer your country is, the slower it will grow. A poor country can grow quickly because it's building up its capital stock and its human capital, as we call it, from a very low base. But once you become well equipped with workers and with capital, you cannot get any more high, simple, easy gains. So in a world with lots of trade-offs, really, with a given time period, there are only so many car factories we can build, and if we want to keep building more factories, we'll have to start using less good land, we'll have to start using workers who are not quite so good. It's a world of diminishing returns, and you extrapolate that to the national level, same thing, diminishing returns. So, back to the paradox. The paradox is, how could there have been exponential growth in the developed countries over the last 200 to 300 years? Exponential growth totally contradicts what we have so far in terms of modeling. So let's go to Romer. Romer says, okay, up till now, the A parameter, the technology parameter, has just been kind of sitting there. If A increases, it has a positive effect, but it's a minor player in the story of economic growth. In the solar model, A is treated something like the weather. Accidentally, occasionally, if you're lucky, A will just bump up a bit, and that's a good thing. But it's not something that we can control or influence. It's certainly not something that government policy can move in a particular direction. So in the solar model, we pretty much ignored A. We just left it in all the equations, but it was just like a constant. Romer's point is that A is actually the main event, the main story of modern economic growth. And what he means, what he's thinking here is that if we think of A as representing ideas about how to produce things, technology, his analogy is that technology is like a set of recipes. The knowledge of how to create a light bulb is something like discovering the recipe for making a light bulb. Now here's the great thing about recipes, about technology. Once somebody discovers a new and better way for making a product, it doesn't have to be rediscovered. Once the light bulb was invented, once a cure for cancer gets invented, nobody else has to do it a second time. And that means that once somebody discovers something valuable in a production sense, in a beneficial sense, everybody can benefit from that idea without subtracting from anyone else's benefit. So, I discover a cure for cancer, maybe I'm better off, but you can take advantage of that knowledge as well, and so can the next person and the next person, and the billions of people on planet Earth can all benefit from a cure from cancer without in any way diminishing my individual benefit from that discovery. Ideas are non-rival. That's the essence of it. Unlike an apple, where if you eat it, I cannot eat it. In the case of an idea, if you have a great idea for producing more stuff, you can benefit from it, but I can benefit from it as well, and neither of us is worse off by sharing that invention or discovery. As George Bernard Shaw once said, if we exchange apples, each of us still ends up with one apple. But if each of us has an idea and we exchange ideas, each of us has two ideas. That's the difference between the apple, the rival good, and the knowledge of how to create a light bulb, which is like a non-rival good or a non-rival object or a recipe that can be shared. So this non-rivalry of ideas gets us out of the diminishing returns trap. It gets us out of the diminishing returns box. And the implication here and the idea and proposal from Romer is this new idea generation is the only way to generate fast progress on a global scale. Ideas or inventions, if you want to call them that, have to be the explanation for what happened. They're the only thing that can generate a benefit so huge it can actually give you exponential growth. Now, let's talk a little bit about how we generate good ideas. And it isn't so simple as just wanting them to spontaneously arise. And the example that he gives is the case of a company that invents a new antibiotic. It cost them $800 just to discover the recipe for the antibiotic. Now they're ready to produce. The costly bit was discovering the formula or recipe. To create a dose only costs $10 in terms of labor and capital. Now let's suppose they produce their very first dose on day one and then they stop. That's it, they produce one dose only. Well, it's a very expensive dose because it took them $800 million to discover the recipe plus $10 to actually produce the first dose. So in a sense, producing dose number one cost $800 million and $10 to produce. Now the good news is if they produce a second dose with an extra $10 cost, now they're dividing the cost of producing each dose by 2. So 800 million and $20 divided by 2 give you a per dose cost of 400,000 and $10, and so on. As we start producing lots and lots of doses and maybe millions of doses, the per dose cost goes down. You're spreading the fixed cost of the invention over more and more doses. So as we scale up production, the cost per dose falls, and we call this increasing returns. So here's the diagram from the textbook that gives you the idea. On the right there, you see to produce that very first dose, it's under the axis Y. That's like measuring doses. Well, that was kind of interesting. I just had a little mini earthquake tremor thing happen. But not to worry, I'm still here. I wish someone would invent a way to deal with earthquakes or predict them, but never mind. Let me continue. Okay, so the diagram on the right, you see there that output goes up 800 million, the first dose. As you produce many more doses, the average cost goes down. We call that increasing returns to scale. Actually, well, don't call it increasing returns to scale. We call it increasing returns. So at this point, everything seems great, assuming the firm can sell a lot of doses. It will work out, right? They'll spread the fixed cost over many doses. Well, wait a minute. There is a problem. Here's the problem. Now that the antibiotic formula has been discovered, what's to stop another firm coming along and saying, okay, we'll produce doses at $10 each or $9 each. They don't have to cover the antibiotic cost, the antibiotic discovery cost, because they didn't create the invention. Now, if the first firm understands that this can happen, why would it invent the antibiotic in the first place? Why should they incur $800 million in cost just so a competitor can come along and start stealing their customers, as it were? This is why we need the government, in this case, to make some adjustments to the way the market works. And the usual way is to grant patents and copyrights. So the company that invented the antibiotic gets a limited term exclusive monopoly on exploiting that invention. Maybe it's like 20 years or 25 years or 30 years, something like that. That gives them a chance to recover their costs, make a profit, and have the incentive to create the antibiotic formula in the first place. So once we start getting into the importance of inventions and discovering new things and ideas, we now have to think carefully about how you incentivize people to create these things which are not physical. You can't lock them up. How do you deal with the problem of the incentive to create the new ideas? Now, Roma has a formal model that the textbook goes through. I'm not going to go line by line with this with you here. I assume you've had enough practice at this point. You can do that yourself. I'll just show the basic things. Here's the essence of the Roma model. The essence is that K has been taken out of the model, so you don't see K anymore. Something is added in, though, And what's added in is a mechanism for producing ideas, a mechanism for increasing A. In the other model, previous solar model, A was just a parameter. It was what it was. You could not control it. But now we have, as you see there, a mechanism by which A gets increased, an idea production function. That's the third equation down there. Delta A t plus 1 equals Z with a bar times A subscript T times L subscript AT. So we now can cause A to keep on going up. Now, the way we create new ideas is we divide our workforce into two types of worker. LYT are workers who produce the usual sorts of consumption goods. LAT are the workers who are dedicated to producing new ideas. So you see LYT plus LAT equals L bar, the total labor force. You see YT equals AT LYT, that is total production in the economy of goods, like consumption goods for consumption purposes, is equal to AT times LYT. So LYT are the workers producing regular consumption goods, and AT is the multiplier for what they produce. Now, the Z bar is a sort of productivity in producing ideas parameter. So LAT are the workers who produce ideas. They have their efforts multiplied by the technology parameter AT, plus there's a ZT sort of a effectiveness of the knowledge workers component, and all that goes into producing the increase in AT. If this is the first time you've seen all of this, then don't worry if you don't understand it the first time. Okay? It's in the text, it's in my notes. To summarize, the essence of the Roma model is it takes K out of the picture and it creates two classes of worker. One class of workers is dedicated to increasing knowledge, which causes A to go up, which makes the economy more productive. That's, in a nutshell, the Roma model. So, to summarize a few equations, the labor force, L bar, is divided into the workers who work on producing consumption goods and the workers who focus on producing new ideas. The workers who create new ideas have their efforts magnified by the A and magnified by their effectiveness, the Z bar, in the effectiveness in creating new ideas. Dropping down to the last equation, the YT equation tells you the path that output will take beginning in period 0 all the way into the future as T becomes bigger and bigger and bigger. Initially, you start with a little bit lower consumption goods because some of your workers are busy making ideas. That's the 1 minus L bar thing. You're subtracting off the fraction of workers who are focused on idea creation. But over the long run, you see the 1 plus G bar all raised to the power T. Over the long run, those ideas have a compounding effect on the economy. The rate of growth of ideas multiplies upon itself. The more ideas you have, the more benefit you get from the new ideas, because new ideas sort of magnify the effect of the old ideas. So over the long run, investing in creation of new ideas pays off big time, and you notice 1 plus G bar raised to the power T is the sort of term that will give you an exponential shape to growth. Now, in this exact configuration of equations, for reasons I don't want to get into in the video, what you get from this precise setup is, over the long run, you get a constant growth rate, and output per person keeps going up in a straight line, and it does not diminish. It does not flatten out. So even if you're rich, you can keep getting richer into the indefinite future because of ideas. And another consequence that's not so obvious is you cannot be sure there will be convergence of countries. It's possible that even if a poor country starts having a good growth rate, it might never catch up to the rich country. Now, the poor country will become richer and rich, but it's not inevitable. There's no certainty that everybody will end up exactly the same place for GDP per capita. Now, I'm going to post 2 videos from MR University, the Solo model and ideas, and the economics of ideas, and I want you to watch those videos, and I will assume that you have watched them. So see you on the next chapter.